So, today we're going to learn about a different type of Boolean logic, or, well, we're going to learn the more complex things. So, imagine this, on the question paper there is a truth table and they ask you to derive an expression. They ask you to derive an expression from the truth table given below. And the only thing that you have is this truth table. Okay, it can be anything though. It can be anything, but this is what I wrote. Okay, it can be anything though. So, how do you approach a question like this? Okay, so the first thing that you want to do is you want to mark out all of the inputs where the output, which is x is the output, right? Where the output is 1. So that is going to be line 1, line 5, and line 7. So these two, they're going to be the ones that we're focusing on. These three are going to be the ones that we're focusing on. Okay, now what you want to do next is you want to write down ABC, all right, and again ABC, all right, all the times that you found these lines. Okay, so ABC, all right. So I found 1 3 times as the output, so I'm just gonna write ABC, 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 right? So now what you want to do is wherever A or B or C is a 0, you want to add a not there. Okay, so this one signifies the first line, this one signifies the 5th line, and this one signifies the 7th line. Okay, so let's look at the first line. 0 0 0 1. The output is 1, and A, B, and C, all of them are 0, so we're gonna make them 1. Okay, so not A, not B, not C. All right, and then let's move on to the 5th line, which is this middle one. So A is already 1, so we don't need to touch that, whereas B is 0, so we're going to do not B, and we're going to do not C. Then let's move on to the last line, which is this line, the 7th line, which is in which A and B are already 1, so we don't need to touch them. We're just going to touch not C. Okay, now you have all of these lines. What you're going to do is you're going to combine them using an AND gate. You're going to combine them using an AND gate. So just add AND in between them. Alright, so this is what it should look like at this point. Okay, and not C. Alright, now the next step is to just add all of these together with an OR gate. The brackets, the groups, you just want to add them both together with an OR gate. And that is how you derive a logical expression from a truth table as given below. Now, the logic behind this is simple, okay? The reason they ask you to find ones is so that you can check out A, B, and C, and wherever either one of those values is 0, they ask you to turn it into a 1 using a NOT gate, and then they multiply them all together to create a 1 as the output. So this wouldn't be valid here because this 1 would become a 0 and these would be a 1, so the output would be 0, right? So this is basically how it works, and the OR at the end is just used to signify their unique positions, right? So that is exactly how it works. Let's do another one. So you have okay, let's create another truth table. I'll just copy this. I can't copy this. Oh, that's okay. I can copy this. Okay, and I'm going to paste it. Okay, I'm gonna create another truth table, and we're gonna look at it that way. All right, so this is going to be a 1. Let's make the top one a 0, and let's make this a 1, this a 1, this a 1, and this a 0. Okay, so like I said, step 1, you want to mark out all the x's, all the rows where x is equal to 1. So that is row number 4, row number 6, row number 7, and row number 8. Now, the amount of times that you just marked it out, just write in parentheses or in groups A, B, and C. Okay, you can do this as a rough work or whatever suits you. Okay, now you got 4 groups, 4 rows, 4 groups. Now what you want to do is go over each one of these rows and see where either one of the values A, B, or C is 0. Right? So for instance, here A is 0. So what we're gonna do is we're gonna write not A before A. Right? A is 0, so we wrote not A to make it a 1. Alright? And the rest are, we can keep the rest as they are because they're already 1s. Let's move on to the second row, the 6th row, where A is already a 1, so we don't need to touch A. B is a 0, so we do need to touch B. We need to make it a 1. And then C is a 1, so we don't need to touch it. Let's go on to the 7th row. A, B, and are okay. The C is the only one that is a 0, so we're just going to add a not in front of C. And then the last row, the 8th row, all of them are 1, so we don't need to touch any one of them. Alright, now step number 2 is to combine all of these letters with an AND gate. Alright, you're going to combine all of these letters with an AND gate. Okay, and okay, and now last step is you want to add an OR gate in between them all. Okay, just want to add an OR gate. Okay, now this is insanely long, but if they ever give you a statement like this one right over here and you're confused, like there's no separate grouping, you can just start from the left. Okay, you can add grouping yourself. You can just group this part right over here, and that will make it much easier for you. So always start from the left. You do this, then you do this, then you do this, then you do this, then you do this whole thing. Alright, so you can start from the left, you can group it yourself as long as it starts from the left. Alright, if they give you something like 3 inputs and no grouping to help you with them. So this is these are two truth tables of the same practice. Let's actually see how we can create this first one. Okay, let's draw a diagram to represent the first one. Okay, so like I said, you gotta group these. If you haven't already, it will make it much easier for you. If you think that you can do it without the grouping, no worries, but grouping it left to right, it's always gonna make it easier for you. Okay, which is what I'm gonna do. All right, let's write the 3 letters. Okay, you got A, you got B, and you got C. Okay, so what we're gonna do is we're gonna start at this line right over here, then we're gonna do this one, then we're gonna do this one, and then we're gonna do this one, and then we're gonna do this one. Now this is an extremely hard logical circuit to draw, so if you don't get it, don't worry. Okay, all right, so right here inside of these you can also group these. All right, to like not get you confused or anything, you can group the 3 inputs inside as well. You just group A and B. All right, so you can just group them as I'm doing. That will make it much easier for you to understand and create. All right, now okay, so let's start off with the first statement, which is not A and not B. All right, so let's bring out A, let's add a not gate. All right, and let's bring out B and add a not gate as well. All right, so now we have not A and not B. Now we gotta add an AND gate. All right, we gotta add an AND gate, and that is this statement done. Now the output of this statement, this small statement, is going to be ANDed with not C. So let's bring out C. Let's bring out C, and okay, and let's take the not. Let's take the not of C. All right, and let's combine this not with an AND gate with the value that we just took out. And that is this whole statement done. Alright, now what we're going to do is we're going to move on to the next one, which is A and not B. So what you can do is you can bring it outward. So I can just do like this, add a little dot to tell me that A is being extracted from here, and take a line to bring it out. And not B, we don't need to bring it from here and add an odd or a not gate again. We can just simply extract B from there. Please don't override over circuits. I'm on a laptop right now, which is why my drawing is so bad. Okay, so A and not B. Alright, so we did A and not B. Right, so this statement is done. Now it's time to get not C and AND it with the value that we get from this small expression that we just made. Alright, so that is right there, is this whole thing done. Now let's OR it with the first original value. So we're gonna add an OR gate. Alright, and we're gonna add these values to it. Alright, and now we have completed basically 2/3 of the expression itself. Okay, now let's move on to the final statement, which is going to be A and B. So we're gonna bring it further apart. Let's just bring B over here, and we're gonna extract A from here as well. Alright, and we are going to add an AND gate to represent A and B. Alright, A and B. So that part's done. And not C, so we're gonna bring this out. Okay, and we can simply just extract C from in here and just bring it over here. And what we're gonna do is we're gonna add an AND gate, because this is not C and A and B, so add a NOT gate. And now we have this part of the expression done. Now the only thing left is to add the last OR gate. Okay, so what we're gonna do is we're just gonna bring this input down here, add an OR gate, and yeah, that is how to draw the logical circuit from just a logical expression. This was an insanely long logical expression, but the output of this logical circuit will give you this truth table right over here, if I did not make a mistake. All right, so let's do another question. That is, let's do another different question that is related to Boolean logic. All right, that is going to be the give me a second. Okay, so what you're given is you're given either a statement or a truth table. Okay, how does that work? Okay, let me show you. All right, so imagine this: you are given a statement. It is said to write the logical expression for a system which gives the output of open when A and B and where A is on and B is on and C is off. Okay, now this is an extremely easy question. Alright, let's just say it's 3 marks. 3 marks. Just write the expression. Alright, let's see. So, first thing, whenever they give you the blank, all you gotta do, the first thing that you should do is write X is equal to, okay, or whatever the output is. Output X, whatever it is, write it down, okay? X is equal to, now what we're gonna do is we're just gonna look at this, okay? A is on, meaning that A is 1, so we're not gonna touch A, okay? And then they literally said in the statement and, so we're just gonna write and. B is on, so we're not gonna touch B, and then they wrote and again, and and C is off, meaning that we're gonna do not C. This is literally 3 marks right over here. Now you can group this as you like. You can group A and B. Alright, and if we draw the truth table for this, you're gonna see something really cool. Okay, so let's draw the truth table for this. 3 4 4 by 8, and okay. Alright, so A, B, C, and X. Alright, so 0 0 0 0 1 1 1 1, and then you got 0 0 1 1 0 0 1 1, and then you got 0 1 0 1 0 1 0 1. Alright, so let's just add some letters. So we're gonna do D and F. Okay, I'll add 2 more columns to this table. Insert right. Okay, so let's just add D and E. What are D and E? We learned previously that you can assign letters to these, so we're gonna assign D to this, and we're gonna assign E to this. Okay, so that's right. So A and B, we're just gonna multiply it together, so it's gonna be 0 0 0 0 because the first 4 statements are 0, then 0 2 zeros again, 0 0, and then 1 1. Alright, then you have E, which is not C. Alright, so we're just gonna make everything the opposite. So 1 0 1 0 1 1 0 1 0. Alright, and then you have the final one, which is the X. Alright, which is the insert right, okay, which is the final answer after this AND gate is added. Okay, that is X. Alright, X. So it is the AND of D and E. So already first 6 are going to be 0 because these first 6 are zeros, and then this one is gonna be a 1. 1 times 1 is 1, and then 0 again. Okay. Now, if you forget about D and E for a second, and look at the question where A is on, B is on, and C is off. Okay, C is off. You can already see of all of the combinations, the only one that turns out as 1 is where A is on, meaning it's true, meaning it's 1, and B is on, meaning it's true, meaning it's 1, and C is off, meaning it's false, meaning it's a 0. Alright, so that's the only occasion when it's actually a 1 as the X. And a similar paper came, and a similar question came in May-June 2024. Alright, so let's see. So let's do another type of logical question. Alright, for this we're gonna need 4 columns. Let's add 4 columns to our thing. 4 columns, and we're gonna need 6 rows, 7 rows. Alright, so this one is a bit different. Okay, how this one works is that they're going to give you a table. Alright, it's gonna have all of these fancy words inside of it. Okay, so for instance, this one that I found from the Hotter book, parameter description. These questions, I get them from the Harder Education Computer Science book, 2nd edition. The parameter, the I'll just extend this honestly. Alright, the binary, and the description of condition. Alright, so let's talk about parameter description. So this is gonna come in these types of questions. Okay, so this is going to be turbine speed, this is going to be turbine speed, this is going to be bearing temperature, this is going to be bearing temperature, this is going to be wind velocity, this is going to be wind velocity, this is going to be SSTTWW, and then this is going to be 0 1 0 1 0 1, and this is going to be turbine speed is less than or equal to 1000 RPM. Turbine speed is greater than 1000 RPM. All right, and then you got bearing temperature is less than equal to 80 centigrade. Bearing temperature is greater than 80 centigrade. Wind velocity is less than equal to 128 kilometers per hour. Wind velocity is greater than 120 kilometers per hour. Alright, so this is how the table would look like. Now the question itself will have a statement below it. For instance, either turbine turbine speed is less than equal to 1000 rpm and bearing temperature is greater than 80 degrees centigrade, or turbine speed is greater than 1000 rpm and wind velocity is greater than 128 kilometers per hour, or bearing temperature is less than equal to 80 degrees centigrade and wind velocity is greater than 120 kilometers per hour. Alright, so this is what the statement would look like, right? So what you want to do here is you want to basically, first of all, you want to separate these. Okay? So the main statement is going to be the output x will have a value of 1 if any of the following combination of conditions occur. Alright, so what you want to do first is, on a rough sheet of paper using pencil or whatever, you want to divide this. Okay, so you're going to write turbine speed is less than equal to 1000 rpm and bearing temperature is greater than 80 degrees centigrade. Okay, then you're going to do the same thing for the other one. Turbine speed is greater than 1000 rpm and wind velocity is greater than 120 kilometers per hour. Right? Or the last one, bearing temperature is less than equal to 80 degrees centigrade and wind velocity is greater than 120 kilometers per hour. Now you have three different conditional statements. Now what you can do is, in front of them you can write their different expressions. How would that work? Okay, so you want to first go ahead, look up this value on the table. So turbine speed is less than equal to 1000 rpm. That means that it's a 0. So what we're gonna do is we're gonna write not, and then we're gonna look at the parameter. So it is s. So we're gonna write not s. All right, and they use an and in between. So we're just gonna convert that, and we're gonna write in uppercase. And bearing temperature is greater than 80 degrees centigrade, which is already a 1, and the parameter is t. Now this can be confusing, but all you have to do, remember, look at the statement in the table itself. Okay, if it's a 0, then add a not before the parameter. If it's a 1, then just add the parameter itself. Okay, now instead of ABC, we're using custom parameters. Okay, all right, so next statement, it is going to be turbine speed is greater than 1000 rpm. That is already a 1, so we don't need to touch that. And wind velocity is greater than 120 kilometers per hour. So it's right here. All right, this is supposed to be a greater than sign. It's right here, so we're gonna write an and, because there's and in between as well, and W. Simple, because it's not a 0. You don't need to convert it. All right, lastly, we're gonna do it for this one. So that is going to be not t. All right, because it's a 0. All right, we're going to convert it to a 1, and we're going to add an and. Wind velocity is greater than 120 kilometers per hour. It's already a 1, no need to do anything. So these are our three logical expressions. Not s and t. S and W. Not t and W. Now if we go back to the original question, they told us or. Either or. So we're just going to add an or gate in between. They can tell you either or. They can tell you if and they can tell you anything. Okay, it's your it's your thinking of how you wanna use. Okay, they say or, you're gonna use an or gate to combine all the different expressions that we just came up with. All right, so this is our logical expression. Let's draw the truth table for this. Okay, how do we do that? Well, we're gonna group these first two things. All right, just for the ease. All right. Now what we're gonna do is we're going to assign each one of them letters. So we're gonna assign the letter A to this, to not S. All right, this is going to be A, and this is going to be B. This is going to be C. This is going to be D. This is going to be E. This is going to be F, and that is already X. All right. Oh yeah, I forgot. You should need to add X is equal to. Okay. You need to add X is equal to. So 1, 2, 3, 4, 5, 6. 6 extra values. So let's get to work. All right. So 6, 7, 8, 9, 10. Great. All right. So let's begin writing the truth table. So A, B, C already provided. 0, 0, 0, 0, 1, 1, 1, 1. You can memorize this if you want. 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1. All right. All right. So, sorry about that. And okay. So 0, 1, 0, 1, 0, 1, 0, 1. Now we assign the letter A to not S. Okay. Sorry. This is S. I miswrote this. S T W. Okay. So let's do A. So A is going to be not S. So 1, 1, 1, 1, 0, 0, 0, 0. All right. Then let's do B, which is going to be A or not S along with T. All right, an AND gate between them. So B is going to be S not S, which is A and T. All right. So it is going to be 0, 0, 0, 1, 0, 0, 0, 1. Okay. Sorry. No. I was looking at the wrong value. So this is going to be a 0. And okay, this is going to be a 1. So 0, 0, 1, 1. Yeah, okay. So this is B. All right. Now let's do S and W. S and W is going to be our lovely old C. All right. So S and W. So that is going to be 0, 0, 0, 0, 0, 0, 1, 1. All right. Then let's do E, which is going to be the value that we calculated, which is B, or C. So B or C, that is going to be 0, 0, 1, 1, 0, 0, 1, 1. Okay. Now let's do D. D is going to be not T. So that is 1, 1, 0, 0, 1, 1, 0, 0. All right. And then F is going to be not T, which is D and W. So this and this. So 0, 1, 0, 0, 0, 1, 0, 0. Now what's gonna happen is we're gonna do an OR gate between F and E. So that is going to give us 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is going to be the truth table for the statement above. And if we look at this logically, if the turbine speed is less than equal to 1000 RPM, which is a 0, all right, so S is a 0, and bearing temperature is greater than 80 degrees centigrade, so T is a 1. You can see that every possibility with 0 and 1 is a 1. All right, same here. Turbine speed is greater than 1000 RPM. Right here it is a 1, and wind velocity is greater than 120 kilometers per hour, which is also 1. You will see that everywhere where S and W are 1s, it's gonna be a 1. So right here a 1, and right here a 1. So this and this, these were 1s. And lastly, bearing temperature is less than equal to 80 degrees centigrade, and wind velocity. Okay, bearing temperature is less than equal to 80 degrees centigrade happens when T is equal to a 0, and wind velocity is greater than 120 kilometers per hour, so W is equal to a 1. So wherever there is a 0 and a 1, it's gonna be a 1. Alright, and 0, 0, 0 and 1, 0, 0 were never mentioned in the question, so those are going to be default. And that is how these algorithm questions work. And with that, we can mark Boolean logic an end to our parade. We will come back to Boolean logic when we're completed with the syllabus, as one last revision before we head on to topical and yearly past papers. And yeah, so we've done everything from simple gates to circuits, to truth tables, to complex truth tables, how to draw XOR gates, even more complex, even more. We did the how to find out the logical circuit from just a truth table, and lastly we did statement word problems, and we did algorithmic questions. Alright, so that marks an end to today's session as well. Today's was short, and we will probably start our next chapter, which is going to be databases, tomorrow. Alright, today was short. I believe that only 20 to 25 minutes were spent, maybe less, but tomorrow is gonna be much better. Alright, see you guys tomorrow, and yeah, have a nice rest of the day, and goodbye.